This is CAP697 and we're in section 3 for our multi-engine piston aeroplane. In this video I shall show you how to obtain the cruise power setting and fuel flow using figure 3.3, which is the power setting table. Before we get started, please note that these tables are for ISA deviation being 0 degrees Celsius, basically means no deviation. And to maintain constant power at temperature deviations other than 0, so if your OAT is something other than ISA, we will need to make an adjustment. And that adjustment is to correct by adding 1% for each 6 degrees Celsius above the standard temperature, or by subtracting 1% for each 6 degrees Celsius below standard temperature. This adjustment is made to manifold pressure. We don't make it to anything else, only to manifold pressure. Now what happens if the temperature deviation is something other than 6 degrees Celsius above or below? Let's say you're 2 degrees Celsius warmer than ISA. Well, we only make adjustments in 6 degrees Celsius increments. So if we're warmer than ISA by 6 degrees Celsius, we'll make an adjustment. If we're 7 degrees Celsius warmer than ISA, well, we'll make the adjustment for 6 degrees Celsius deviation. The other thing to note, and that's given in bold, is that the cruise manifold pressure must not exceed 34 inches. Okay, so that is an engine limitation. So any value that is bigger than 34 inches cannot be used in this airplane because you will damage the engine. And we only have one value that's actually 34 inches. That's at our high speed setting with the highest fuel flow and the lowest RPM for that fuel flow. And we have 34 inches at sea level. How then do we use this chart? Let's find out by working an example. Let's assume that we will cruise with a power setting of 55%. And at 55%, we can see that the fuel flow is 18.7 gallons per hour. Assume we want to cruise at 4,000 feet at 2,200 RPM. What would be our manifold pressure? So this would be the column that we're interested in. We'd like to cruise at 4,000 RPM. So our manifold pressure would be 29.2 inches of mercury. And it's that simple. However, let's say we'd like to cruise at 5,000 feet. Then we'd have to interpolate between 4,000 and 6,000 feet. So our value now would fall between 29.2 and 28.8. So we'll simply add these together and we'll divide by 2. And we get a value of 29 inches of mercury. And it's that simple. The remaining thing to do is to make a temperature adjustment. And that adjustment is either adding 1% or subtracting 1% depending on is our ambient temperature actually 6 degrees above or below the standard temperature. If our actual temperature doesn't differ by more than 6 degrees Celsius from standard temperature, then we do not need to make any adjustment. And that's how we use the power setting table, figure 3.3.